Okay, another video quickly on improper integrals, and they relate very closely to series convergence. Now the first one I'm looking at is the integral from 1 to infinity of 1 over x dx. The way I would evaluate that, I'd take the limit as b goes to infinity of 1 to b of 1 over x dx, the antiderivative being ln of x. And you can see that the limit as b goes to infinity of ln of b minus ln of 1, which is 0. ln of b is going to infinity, so it will diverge. And this you should recognize by the p series, that 1 over n, the sum from 1 to infinity, is going to diverge. But if I look at 1 over x to the 1.01, or anything with a higher power than 1, it's going to converge. But let's do it. Limit as b goes to infinity of 1 to b of x to the negative 1.01. That actually, the antiderivative, I add 1 to that negative 1.01 and divide by the negative 0.01. And that works out to be limit as b goes to infinity of negative 100 of b to the negative 0.01 minus 1. But b to the negative 0.01, that's the same as 1 over b to the 0.01. That's going to 0. It's going to go slowly, but definitely as b gets bigger and bigger, that's going to go too. So that will converge. So you can conclude anything with a power greater than 1 when you integrate will converge. Now I'm going to switch gears, but those of you who recognize, or you might see something that might save you some time. Now clearly by what I just did, 1 over root x as the integral from 1 to infinity will diverge. But what about if I go from 0, say, to 4 of 1 over root x? This is also improper because I have an asymptote at 0. So let's do this. The way we'd set up this limit is we'd say the limit as b approaches 0 from the positive side of b to 4 of 1 over root x, or x to the negative 1/2, is the limit as b goes to 0 from the positive side of 2 root x. That's the antiderivative. And that converges to 4. So let's look at 0 to 4 of 1 over x squared dx. What about that? Same thing, limit as b goes to 0 from the positive side of x to the negative 2nd, the antiderivative being negative x to the negative 1st from b to 4. And I'm going to end up with the limit as b goes to 0 from the positive side of negative 1/4 minus negative 1 over b. But 1 over b as b approaches 0 from the positive side diverges. So, in reviewing, going from 1 to infinity of anything with a power greater than 1 will converge. Anything power of 1 or less diverges. But when you look at it when it's approaching 0, meaning the asymptote's at x equals 0, and I'm climbing up the y-axis, it converges if the power is less than 1, and it will diverge if the power's greater than 1. I hope I didn't confuse you, but that's a good thing just to have in your pocket. Okay.